Good evening. Hello, can you hear me? Yes, hello, can you hear me? And can you see my screen? Hello? Yes, so kindly confirm. Hello, can you hear me? Hi guys. Let me type. Yes, can you hear me? Kindly. Hello? Hello? Good evening. Oh yes, thank you, Isaac. I can see you can hear me now. Yes, I'm audible. Yes, so I was trying to confirm. So I think we can start. Yeah, so basically for our session one today, I have a slide here that I'll share after this session. We are now trying to explore advanced Python concepts in such a way that we are trying to transition from the basics that we did to now production ready Python. So during our basics, or let me call it fundamentals, so it should be fundamentals, not basics. We discussed some concepts in Python where we had variables, we did data types, then we did conditions, we did looping, and we also talked about functions. So for today, we want to move from those basics to production. So if you're talking about production, we are trying to think about Python programs that can be used in production ready applications. Okay. So this is actually what we are going to cover today. So if you are taking some notes, we will be giving the analogy of the show you the syntax, so the code, and then we are going to show you how that concept can be applied in the AI reality, like in our production. For example, LangChain, Fast API, large language models. Analogy in such a way that how the logic is used every day. And then we're going to show you the code and then how to apply that knowledge in the AI reality. Okay. So the concepts that we have today, I think maybe we can list them before even proceeding. We have the concepts are here. I think make sure, I don't know whether you have this notebook. Do you have this notebook? This one here, session one. I had shared with you yesterday. Yes, so kindly, I hope you have it. If you don't have it, then I'm also sharing it on the chat. Where's the chat? So I'm sharing the notebook on the chat. Okay, so I've shared with you the notebook. So today, basically, we want to discuss 5 advanced Python concepts, 5 of them. Then we're going to show you how they are going to apply in our AI applications. So the first one we're going to talk about is data structures. So if you're noting somewhere, we'll be talking about data structures. And in data structures, we are going to compare a list and a set. So we're going to basically talk about why data structures. The first one is data structure, if you're noting it somewhere. So that is the first concept we are going to cover. Very, very important in a lot of applications. The second one that we're going to talk about today is object-oriented programming, okay? So that is the second concept that we're going to cover. And basically about classes and objects. So we're going to differentiate what is a class and what is an object, and how can you apply object-oriented programming into your AI applications. So that is the second one, very, very important. It's very, very important. So decorators. The fourth one we're going to talk about is generators. Generators, this one here. And then finally, the last one, the fifth one, will be Pydantic. So Pydantic, we are going to focus on data validation, which we are going to see later that as people are using how to validate information that are being generated by these AI tools. So that's why this is also very, very, very key, okay? So without any question, I will use the notebook to actually elaborate more about these 5 concepts. So as usual, maybe someone could be researching for us. Let's start with the first one, data structures. Let's start with the first one, data structures. So maybe someone can research for us what is data structures. Maybe you can use ChatGPT or any other tool that you have, Cloud if you have it, or Copilot. So maybe someone can research for us what is data structures. And then someone else can research for us types of data structures in Python, okay? So what is data structures? And then types of data structures. So we have several types of data structures, but for this lesson, because it's very, very short, we are just going to compare between list and set, okay? So anyone who can volunteer to what is data structures? What is data structures? And to even say it better, if you actually do a lot of these interviews with these big tech companies like Google, most of their interviews on data structures. So anyone who is there, if you have something, you can actually pass it on the chat. Then we can go through it, and then we compare with what I have. Okay. So data structures. Who was it? So if I check my slide here, as you're researching on it, the first one is data structures. So a list and a set. So I think in my own understanding, as you're researching, out you're researching about it also, data structure is basically how software developers or AI engineers organize data. So how you're going to organize your data is what we call data structures. How data is organized in your application or in your AI model. That is what we call data structure. I think I've seen one. Let me see. From yes, so Magdalene, you typed types of data structure in Python. So maybe I can type it for you. So the first one that I wanted you to research on is what is data structure. So that by us understanding data structure, now we're going to understand why they are important. So that is the first one. Then the second one, types of data structure. Types of data structure. So I'm doing this one because as you're going to notice in our intermediate level AI, most of the items you are going to research on them. Okay, so you're going to embrace the power of doing research. Very, very key, because as an AI engineer, you're going to meet a lot of uncertainties as you're building this project. So the best thing you can do is to actually have the idea of research. Yes, so thank you, Magdalene. So I think you've researched for us the first one. So yes, according to Magdalene, you're saying that data structure are ways of organizing or storing data. So that is what we call data structure. It's very, very important, especially if you're now building advanced applications. Okay. So if I go back to, I don't know who has found types of data structure, who has found types of data structure. So Magdalene, you are saying that data structure is basically ways of storing and organizing information in your application. So remember, in our beginner series, we had talked about lists, we talked about tuples, we talked about sets and dictionaries. So basically, these are data structure. That is true. Yes, thank you there. These are data structure because we are using them to store information. Okay, we are using them to store information. But now, the way we use different data structures determine how our application is going to behave. For example, this is actually a good example. A good example. So we have actually realized that data structure is a way to store and organize information. So let's say you're building a shopping cart. You're going to use a list. Because if you're using a list, then order should matter in such a way that bread it's on top. And then if you're using a list, duplicates are allowed. Remember, you can have 3 breads, 5. Yes, a question? Yes, a question? I don't know. Someone with a question? If you have a question, please, actually, you can pass it on the chat. Yes, I was talking about a list. It's a data structure. It's a data structure. It's a way that someone can store information. For example, if you're having a shopping cart. Okay? Now, the disadvantage of a list is that if you're trying to search information inside the list, the application will be very, very slow because we have to go in the order on how those items were being stored in a list. So order should matter. That's why if you're searching item in a list, the application will be very, very, very slow. Okay. Now let's have another example. Let's say you have a VIP list. So with a VIP list, duplicates are not allowed. Okay, so we cannot use list to store VIP list because it allows duplicate. And then because no duplicate is allowed, we can actually search instantly within a set. Okay. Here in reality. So let's go to the reality world. Let's go to the reality world. of AI. For example, you have built a large language model and you're trying to filter profanity. So profanities are words that should be restricted within the AI application. Okay, there should be illegal contents within AI application. So anytime you build a large language model, these words should be filtered out. So that is the scenario. Now, if you use a list and you want to scan through 50,000 banned word one by one, the application will be very, very, very slow. I hope you can see that one. So instead, you can work with a set in such a way that because there is no duplicate, checking 50,000 words within a set, it's very instant. Now, the takeaway here is that always use sets for NLP lookups. So that is actually the first idea that I wanted to bring into the page. We need to think about data structure. So I had a code to demonstrate that one. Data structure. So if you have a shopping cart, you can work with a list because the order matters. But if you have a VIP list here, we work with a set so that we don't allow duplicates. And we can actually make searching easily within a set. So I wanted someone to research for us different types of data structure that I wanted you to research more about. Here I can type it on the chat. So as you proceed, maybe you can check my chart, more advanced data structure that you're going to meet in a lot of companies. I think the first one is something we call a linked list. The second one, we have tag. I think we have queue. So these are very, very advanced data structure. Yes, I think these are the ones. Yes. So these are more advanced set tuples dictionary, especially if you're building very complex application, you're going to meet linked lists, tags, and queues as other types of data structure. So what I wanted you to do during your own free time, because this is not a data structure class, you can research more about these ones. Remember, data structure is actually a course on its own because people are learning how to store and organize information effectively. And in the same time, we are trying to ensure that those information can be accessed easily. Let me give you a very good scenario why data structure is very, very important. Let's say you are being hired in a company like Facebook. Facebook has millions of users. It has millions of users. So we need someone who is able to store these users in a very efficient manner so that if someone searches, let's say one of the users in Facebook, is very, very easy to find. If you go to Microsoft, it's the same. If you go to Amazon, it's the same. So in most of these big companies, most of their interviews are based on data structure. So if someone asks you today, what is data structure? In simple terms, these are ways of storing and organizing data so that they can be accessed easily. Any question up to there? Any question with data structures? I think we did have more out there. We did have more. Yeah, so in the AI reality, for example, if you're using something called natural language processing, we normally check if a word exists in a vocabulary of millions of words. A list would actually crash your server. A set would work better. So there is a scenario where we can work with a list, a set, a tuple, a dictionary, and even more advanced data structures like linked lists, tasks and queues, which I think you're going to research more about them. Any question up to there? Any question up to there? So for example, this is actually the set where we have different words that are being used by these language models, okay? So we need a way to actually search whether they are there. So the easiest way you can work it is a vocabulary. So as someone is learning more about data structures, I wanted to give this one also to also understand. Normally, they are measured in two ways. Time complexity, and the other one is space complexity. So I've typed them on the chart. Those are the two ways you can actually measure a data structure. The most efficient data structure should utilize less amount of time. That's why we are measuring time complexity. It should actually use less time, and it should consume less memory. So in terms of memory, now we are talking about, sorry, we are talking about space complexity, okay? And that's what, actually, that is the world of data structures and algorithm. Any question up to there? I just wanted to understand what is a data structure. Any question from there up to there? Anyone with a question with data structures? So if you find your own free time and you really want to be a Python expert, then you should actually have some idea of data structures, okay? Okay, so let's go to the second concept. So that was the first one. These are advanced concepts. So the second one is here, object-oriented programming. Object-oriented programming. So let's go here, OOP. So most of the people call it OOP, object-oriented programming. So as usual, maybe someone can research for us, what is OOP? Why is it important in advanced application in terms of AI? OOP, object-oriented programming. So maybe someone can research for us, object-oriented programming. And then as you're doing that one, if you want to really understand what is object-oriented programming, you need to clearly differentiate between classes and objects. Classes and object. And in most of the time, OOP is the most confusing concept in programming. So as you're researching, I don't know who can research that one for us. As you're researching on object-oriented programming, maybe I can try to explain it in my own understanding, how I understand OOP. I think we found one from Alex. Thank you so much, Alex. So we're going to compare between what I'm trying to explain and what we've actually researched, so that we actually come to a judgment. So the idea is to understand it on your own perspective. There is a way I understand OOP. There is a way you understand OOP. But so long as have a comparison, we're going to do from Alex and Magdalene, and also mine. So let's start with Alex. Alex is saying that, so kindly go to the chart. Go to the chart. You're saying that centered programming is a programming paradigm. So let's first interpret what is a paradigm. Because if you check, Alex and Magdalene, both of the application have style, is a programming style. So it's a way to write a program. It's a programming style that organizes code around objects, So that is actually the definition of Alex, which is actually very, very true. So if you're using object-oriented programming, it's a style where we organize our code around objects. So let's go up to that point. Let's compare with Magdalene. So according to Magdalene, you're saying that object-oriented programming is a programming style based on the concept of object. Okay, based in the concept of object. And both of you are saying that for you to have an object, an object must have an attribute and a method. In other words, an object can have something we call a state or an attribute and a behavior that we call a method. And this is actually it. Anything around the world is an object. Let's start with I think this one also. Yes, I think Isaac, you've given us a scenario that you're trying to build a video game. Programming is used a lot in gaming and graphic intensive applications. Instead of writing one long confusing list of rules for the whole game, you can use OOP in simple. Instead of having a pile of random plastic, you can have plastic objects. Yeah, so that is actually true. Now let's try to bring it home. Something that we are all together is that object-oriented programming is a programming style that is based on objects. Okay? Now let's go now try to understand now. Now, what is an object? What is an object? So maybe someone can research for us that one. What is an object? So OOP is a programming style that focuses on objects. Now, for us to understand it very clearly, we need to know now, what is this object? What is this object? What is an object? Then from there, after understanding an object, we are going to understand a class. So if you have understood an object and you have understood a class, then that should be it. That should be it. You need to know what is OOP, what is an object, and then what is a class. So in my own explanation, as you're doing your research as well, object-oriented programming, it is actually the modern way of writing programs, okay? Even these modern AI applications are actually applying object-oriented programming. So as we're going to learn more, we are going to apply OOP. Now, this modern way of programming uses objects as their center point. And in other words, now, I'm confusing you, let me on the chart. Now, an object, let's try to understand what is an object. An object is anything that has an attribute and a method. An object is anything that has attributes and behaviors or method. I don't know whether someone has researched for us what is an object. We need to understand first what is an object and why is it being used in OOP. Okay, so in my own understanding, an object is anything that has attributes and behaviors. Let me give you a good example. A person. A person is an object because this person has attributes. So what are attributes of a person? A person can have a name. A person can have height. A person can have skin color. So that those are attributes. And the same person has behaviors. So behaviors is what this person can do. So if you are a person, you can say, you can walk, you can write, you can learn, and so on and so forth. So I want you to think about behaviors as actions that can be performed by an object. Actions that can be performed by an object. So I don't know whether we are together there. Anyone? I don't know whether we're together there. I hope I should be right. So we've actually come to a conclusion that it's a programming paradigm. So this is a programming style that uses objects. So that is something we've come to agree. So it's a programming paradigm that uses objects. Are we together up to there? So it's a programming way where we use objects. And now we also are trying to be in the same page that an object is anything. An object is anything that has attributes, okay, and has behavior. So that is what we call an object. They are called states, while behavior, sometimes they are called actions. So I hope you are now getting that an object is anything that has attributes and behaviors. So let me share this one with you on the chat. Please, if it's not clear, kindly you can ask it on the chat. So I hope you're together up to there. So I can give you an example of what is an object. Let me give you a good example of an object. So I was trying to describe a person. Or let me even use a good one. What about a phone? A phone. Sorry, I don't know this. I was here. So let's now see different objects. So let's try to see different objects. So I hope you are noting this one down. It's very, very important. So the first object I know is, let's say, a phone. A phone is an object. If a phone is an object, it must have attributes and it must have actions or behavior. So what are the states or what are the attributes within a phone? Let me call them attributes. What are attributes within a phone? So it can have, so if you go to buy a phone, normally you check those attributes of that phone. You check something like the memory. Is it 64 GB phone? Is it 128 GB phone, 256 GB phone? So that is an attribute, something it has, something it has. Sometimes you also check, what else do you check? The size of that phone. So remember, an attribute is what that object has. So it has a memory, it has a size. Then sometimes you check SIM. Is it a dual SIM or a single SIM phone? Okay. Let me try one. You also check the color. So in other words, an attribute is what that object has. Now, apart from the attribute, this phone has some actions. What can you do with that phone? So, actions. So actions are also called behaviors. Other people call them methods, what they can do. So what can you do with the phone? You can call. So these are normally functions. You can use a phone to call. You can use a phone to chat. Yes. You can also use a phone to take a selfie. I don't know if selfie. Yes, this one. So I hope it's you're trying to understand it from that point of view, that attribute it was that object has, and then action is what that item can do. I hope you're getting that one. Let me try a different example of an object so that now it is even more clearer. Another object I know is what another object I know is a person. So a person is an object. Therefore, every person have some attributes, like you have an attribute like your age, your height. So these are basically what every human being has. What else? Weight. People have attributes of weight. What else? Yes, your name. Yes, a name is an attribute. And so many other things that people have. So these are what we call attributes. And then, apart from the attributes, a person can also, I think this should have been a comment. Yes, that one to save on time. Just trying to bring that point home. That one. So people can also do some actions. Like, for example, a person can walk, a person can talk, a person can eat. Let me try the last one. Let me try the last one. Because if you're now understanding this one, then now you're understanding object-oriented programming. Let me try the last one because of time. Another object we can talk about is a car. So a car is an object. Anything that has attribute and actions. Anything. And it's almost everything in this world. Okay? So let's talk about car. So if you go to buy a car, what are the attributes you look for? I think I can start with mileage. What else? I can talk about what we take in color. Color. Some people check for consumption. You also check for the model of that car. Maybe it could be Toyota, or maybe it's Ford, or I hope you're getting that one. So a car, it's an object because it has some attributes. And apart from that, when you can drive it. You can drive a car. What else can you do with a car? You can park it somewhere. If you have a car, some people can hire their cars. So I want you to get it from that point of view, that actions basically. Sorry for that one. Sorry for that one. So actions are what an object can do. Attributes are what an object has. So I'm trying to imagine you're building a game or you're building a robot. These items are objects, so they have attributes and they have actions. Are we together up to there? So maybe someone can research for us from their own perspective, what is an object? What is an object? So someone can research for us now, what is an object? So that now we try to compare with now what I'm talking about here. So in my own understanding, an object is anything that has attributes and behavior, or attributes and actions. Are we together up to there? So who can research for us that one? Now then we compare with what I have highlighted here. And then now finally, we now try to understand now what is a class. Okay, what is a class? So remember, we are doing this advanced Python series this week. So but today I wanted us to cover data structures and object-oriented programming. They are very, very advanced concepts, so we don't have to rush on them. We just need to understand them. Because already we know how to write programs, we just need to understand these advanced concepts, data structures. Now we're trying to understand object-oriented programming. So I think I have someone who has said that, Magdalene, you have said that. Yes, that is true. Yes, that is a very, very important point. If you check on the chart, Magdalene has suggested that an object, I think I should write this one. An object is an instance of a class. Anyone else? So now, from that explanation, we first need to understand what is a class, so that now we say that an object is an instance of a class. So anyone else, especially from ChatGPT, these are it's very, very true to say that an object is an instance of a class. That is very true. Anyone else? Anyone else? Did you find anything? Let me see, where can I pick? Because of time. So remember, this class, we are going to really focus a lot on research. Because as you do your research, that is actually, you are understanding it from now your own. Yeah. According to Alex, very important, thank you, an object is a thing that exists, okay, and can be identified as a single unit. Possess something. They should possess something, so they should have attributes and action. Okay? They should possess attributes and action. How to get up to there? I hope this now at least you've understood what is object-oriented programming, and then you've understood what is an object. What is an object? So if someone asks you in the simplest way, what is an object in terms of OP, the best response you can provide is an object is an instance of a class, which you're going to explain in the few. But also you can say that an object is anything that has attributes and actions. That is also very, very excellent. An object is anything that has attributes and action. If you want to demonstrate, this phone I have here is an object. So it has attributes like size, same, color, memory. I can use it to call, I can chat, I can selfie. The laptop I'm using is an object. So I check for graphics. I check for, what else do we check in a laptop? We check for storage. We check for size, display. And with a laptop, you can use it to code. You can use it to watch. You can use it to do editing, graphics, so anything you can do with the laptop. Okay? So I hope you're getting that explanation that an object is anything that has attributes and action. Now, finally, for today, let's now try to understand what is a class. What is a class? And then if you have understood those three concepts, then you are very good to go with OOP. So we've defined what is object-oriented programming. We've said that it's a programming paradigm. So it's a programming style. It's a way you write your program where things focuses on objects. So you focus on objects. So we use objects. So now we've actually go deeper and say that now these objects are anything that has attributes and behaviors. Okay? And we've demonstrated different objects. And I want to give you a very good hint that everything around this world is an object. Yes. Even if you are, let's say you are eating right now as you're going through the class, you're using a spoon. That spoon that you're seeing is an object because it has make and you're using it to eat. So it's also an object. The plate, the house that you're living in. So the house is an object. With an house, you normally check on attributes like bedrooms, tiles, location, the floor, and then inside that house, yeah, you can actually go and take a shower. You can sleep inside the house, and so on and so forth. So anything is an object, and that is the reason why object-oriented programming has become a modern way of writing programs, because now you can model anything from gaming to robotics and so on and so forth. So especially if you're building a game like FIFA, that is entirely OOP because everything you see in that game, it's an object. From the car you're driving, not FIFA, I think we have the ball, the stadium, the players, everything inside that game is an object. Okay, so let me finalize this one. I hope I'm not confusing you. Let me finalize this one. So that now tomorrow we start on decorators. So now, what is a class now? What is a class? So maybe someone can decide for us that one now. What is a class? What is a class? So I hope if you have understood these three concepts, then that should be it with object-oriented programming. You have understood what is OP, you've understood what is an object, and now finally, what you're trying to understand here now, what is a class? Alex, that is true. According to Alex, if you check on the chat, Alex is saying that a class now is a blueprint or a template that we use to create these objects that you're talking about. So you are a software developer or you are an AI engineer and you want to start building objects within your program. You should now start by creating a blueprint or a template to model this object. And that is what we call a class. So a class is a blueprint. I think that is the best name to use. That is used to build objects. So in the best term to actually, the best way to explain a class is in terms of construction. For you to have a house, so remember the house is an object. You need a template on, you need a design. Yes, I think I can even add the name design. You need a design of that, design on how that house will look like. If you want to build a car, you need how that car would look like. And therefore, that is what we call a class. So a class is a blueprint of modeling object. So I can add even a very important point here, class, therefore, it defines the states and behaviors for these objects. I hope you're getting that one, for these objects. So if you're able to understand these three concepts, then that should be it with object-oriented programming. I think Edwin also has a very good explanation here that a class is a blueprint that defines the properties. So remember we said that this is also properties. This is also properties. states or properties, or yes, that defines properties and behaviors of objects. So it is used to implement a lot of data structures within Python. So I think that is very, very deep. But remember, a class is a blueprint that is used to define how objects will look like. So now let's write some programs with what I've been talking about and try to see how OOP, we try to see how OOP works. And that should be it for today's class. I feel like these are very advanced concepts. So if you have any question, always feel free to ask. Yeah. And the best way you can actually learn these advanced concepts, you understanding it from your own perspective. Okay. Because I hope you have seen that we have a lot of explanation on books, on internet. But now, how do you understand it on your own perspective? So let's build some OOP codes. And then now we are going to see this one. And then I'll proceed to counting application. And then in terms of AI, we are going to see how LangChain uses OOP to build agents within AI. Okay. So let's go there. Let's go there. I really want to bring this one home. I want to bring this one home. So let me write a code cell here. Something we've agreed on is that object-oriented programming uses objects. Therefore, for us to have these objects, we need to design them. We need to design them. So some people say that if you understand all this, like you are a god, you are building objects within an application. So you are designing how things would look like. Okay. Like if you see, let me even open an application, like which application looks good? Which one? Someone who was building this application was actually using OOP because everything you're seeing there is an object, including this dialogue. Because for this dialogue to occur here, the developer had to define how the size of the dialogue and everything within it. So let's write some object-oriented programming codes, and then we call it a day. Okay. So let me start with a car. So let's agree that a car is an object. Something we've agreed on. A car is an object. Therefore, if I actually have a class, so the class will actually define the blueprint, how that car would look. So I would start with a class. That is a keyword. And always remember, classes are capitalized. I hope you've seen that one. Classes are capitalized. So I have a car. I want to have cars within my applications. I have a car. So remember, we've said that this is the blueprint that we are going to have to develop objects from. So the first thing we'll have to define here, let me actually put it here. The first thing we'll have to define are properties of how cars would look like, properties. And then from there, we are also going to define behaviors. Because we have a lot of books trying to explain, I hope I've written it well, properties and behaviors. So some people call these properties, some people call them states, some people call them attributes, features, okay? And then for this one, some people call it methods. I like to call them actions, and so on and so forth. So remember, a car is an object. So what I'm look like. Let's say I'm building a game like GTA. If you've or you've actually played games like Need for Speed. It has cars. So if you want to see these cars, we have to first define them. Now here, to have properties, you will create a function. So there is a function created. You create a function, and you've been told that the function should be specifically called init function. Init function. So that is the function that is used to define properties. I'm going to explain that one. So if you're working with object-oriented programming, for you to define properties within a class, we have to use the init function. So how do you write the init function? It is actually 2 underscores, and then you write the word init. So we are initializing the properties for our object. So then from there, you have 2 more init, 2 more underscores, sorry, and then this is a function. I hope you're together up to there. So let me try to explain that one here. So to define properties, this is something you're going to meet a lot. We use the init, init function. We define it. Okay. we define it. We define it. Now, because this function is within a class, I hope you can see that it is inside a class, we'll have to give it a self-argument. So remember, every time you create a function inside a class, I hope you remember that one all the time, it must have the self keyword. Every time you define a function inside a class, it must have the self keyword inside that class. Now, sorry, after self keyword, now you give it your own properties. So remember, a car must have a make. A car must have a model. Yes, there's a year. You can add your own. What else? Consumption. Yes, there's color. And what else? Price. And yes, I think those are enough. But you can provide as many properties as possible. I hope you're together up to there. So we have created a car, which is an object. So we're just defining how it will look like. So that is actually the blueprint. It's the design. So this function is called the init function. It is actually used to define the properties within a class. So it's a function. So remember, this is actually now the most confusing part in OOP. I hope you're going to understand it. Now, for this car to inherit those properties, we'll have to define them here. And we're going to explain this one in a few. Remember, this is the self argument. It represents the class. And actually define it here. I hope you're getting that one. And then from there, we're going to take the model as well. The model will be added to your class. The year will be added to your class. And then the color, I think we didn't add the price. We should also add the price. Yes, like that one. So we say self.price. So if you say self.price, we have to define the price within our class. And the price within our class will be actually, we are going to pass it here. We are going to understand it in a few, so please don't worry. Now let's define behaviors. Let's define behaviors. Let's define behaviors. So with a car, you can actually drive it. How do you drive a car? How do you drive a car? I think this was okay. I think let me just stop up to that point. Yeah, up to that point is driving. So behaviors represent the actions that can be done by an object. So if you have a car, you can drive it. Okay. So you're going to understand this one later in the example that I've used here. Okay. In the example that I've used here. So this is a blueprint. This is a blueprint. Not Magdalene, but Alex, yes, you had said that a class is a blueprint for creating objects. So it represents the designs, okay? And if you're designing a blueprint, you need to define properties, and you also need to define behaviors. I hope that one makes sense. So this is what we call a class. So every time you create a class, you will have this function to define the properties and that other function to define behaviors. Because like we had said earlier, objects have properties and behaviors. Therefore, inside your blueprint or in your design, you must clearly define the properties. And in Python, we use the init function, this one here. And then you need to define the behaviors. So I want to run this code. I want to run this code. So we have a blueprint. And up to this point, now we need to understand why we say that an object is an instance of a class, just like Magdalene had suggested for us. Now, from a design, remember if you have a house, the house blueprint, you can build so many houses. Similarly, from this blueprint, we can have so many cars. Let's see how that one is done. So I think I can create a new code cell here. I can create a new code cell here where we can say that this is the first car you meet. I can call it car one. Car one, its design was built by this class. So remember, for every object, so remember, this is the object. This is the object that we got from this design. So we can have different cars. I can even say car 2, it's still a car, but it will have different properties and behavior. Just like when you go to buy a car, we have different car. The first car has its own properties and behavior, okay? So let's have like 3 cars. Let's have like 3 cars, and then car number 3, it's also a car. Remember, it's also a car. Sorry. It's also a car. So these are the objects that we are getting from the blueprint. So remember, from one blueprint, from this car blueprint, we can now get several objects. Let's start with the first car. Remember, in our design, we had to specify the make, the model, the year, the color, and the price. So let's do that one. For every car that we have, we start with the make. So we can say the first one is Toyota. Yes, so that is the make according to the properties here. So now we are actually providing the properties. So we have Toyota. Which model of this Toyota? You can say this is Toyota TX model. Then we need to specify the year. So remember, we can just give it a string. The year, maybe it's 2019 version. Which color is this car? This color is white. And then finally, how much is it? Okay, I just wanted to provide strings, but you can give it a number. Let me just give it a number. Okay, let me just give it a string. For this one, you can get it for 2.4 million. So the first car, it's an object. It was built from this design, and these are its properties. The second car, it's also a car, remember, but it has different properties. For example, this is Subaru. Maybe this is Subaru. Sorry, this is Subaru. This, what am I writing? Subaru. I don't know which model, maybe Forester. Forester. Which year? Let's say we can say 2014. Which color is this Subaru Forester? Maybe it's, I don't know whether we have a red one. How much is it? For this Subaru Forester, you can get it for 1.3 M. So you've gone to a garage. The different cars that you are seeing, they are objects. And because all of them, they are cars, they were built from one design, a car, okay? Then finally, let me see the last one. It is also a car, but it has different property. I don't know which car. Maybe we have Ford. It's 2021 model. 2021 model. This Ford that you're driving, maybe this time it's black, and it is black. Black. It is black, and maybe you can get it for 3.6 million. In other words, just like now Magdalene was saying, in other words, just like Magdalene was suggesting, an object can also be defined as an instance of a class. If you're saying that an object is an instance of a class, it means that this object was designed from this class car. So it's like something we got from a design. It's a methods. So I can say I've decided to drive car 2. Subaru is the second car. So I can just call the actions to drive it. And this action can be placed within buttons. That's why you can build automatic vehicles, we can build self-driven vehicles, and so on and so forth. Let's see if you drive car 2, let's see what happens. So we're being told that the Subaru Forester is driving. How did it know that car 2 is a Subaru Forester? Because we displayed the make and the model during that action. So if you start a particular car, let's say if I try to drive the first car, then it should be saying the Toyota TX, it's driving. And then finally, if I try, let's say car 3, which car is that one? Ford Ranger. I'm now driving Ford Ranger. So what I was trying to explain with all that explanation was those 3 very important concepts. The first one, I explained what is object-oriented programming. It's a programming style where we revolve around objects. And now I've also tried to explain to you that an object is anything that has attributes and behavior. Therefore, the last thing that we have also tried to explain here is that we will look like. Therefore, inside the class, we are going to have properties and behaviors. Any question up to there? So those were the three main concepts I wanted you to understand from the idea of OO. I can move to now the example I was giving you here. Anyone with a question up to there? Please, if you have a question, feel free. You can always provide it on the chat. Then we can now discuss it together. Let me see. I think we have one. Thank you. Yes, we are going to share it after our today's session. As you're now wrapping up our today's session, I've given even more examples like this one. A cookie cutter, I don't know how it looks like. Right? A cookie cutter. This one here. Let me see the image. Whatever to the image. Is it? Yeah, this one here. I don't know. This one, if I'm not wrong. So this is a cookie cutter. And in the world of object-oriented programming, this is an object. This is an object. So if it's an object, you need to define properties and behavior of define here is the shape of the cookie that we're going to get. Remember, we can have a star cookie, we can have a person cookie, and so on and so forth. So this is a cookie cutter, it's an object. So in other words, a cookie cutter, it's an object. So we can define properties of a cookie cutter. So at the end of the day, we can get the shape of our cookie. And now this shape, I hope you're seeing my cursor. I hope it's visible. Class. Similarly, what we've done here. Remember, you've provided so you've defined will be added to the class. How do you add it to the class? We are using the self argument. So the make that you defined here, Toyota, I hope you can see that one. This make that you define Toyota will be stored in this variable here, make. To the class using the self argument. So let me go back to the cookie. So the cookie has a shape. Okay. So the first cookie that you build using the cookie cutter, the same cookie cutter, you can build a star cookie. Okay. The same cookie cutter you can. As which other cookie do we have? Okay. Cookie 3. Cookie 3, we can actually say square. So every time we are using the cookie cutter, we get up a shape of that cookie. And just like I had explained also, a class must have here. Can add action here. So I can say, cut. Now we can cut the cookie. And as we cut the cookie, we cut the cookie based on the shape that we define. For example, if you now want to cut cookie 1, I think I can now comment this one and do away with them. You're going to end up with a star cookie. Okay. If you cut cookie 2, you're going to end up with the heart cookie. If you define cookie 3, you're going to end up with square cookie. And all these three, they are objects that were defined from this class. So we can also say that they are instances of the cookie cutter class. I hope you're getting that one. So every object must have properties and a neat argument. And then something to remember is that every function within a class must have the self argument. So let me even bring you now to a more realistic example, because so let's talk about a bank account. Yeah, like if you are using client or every customer within I and M, they have a bank account. Every person, they have a bank account. So what did the bank do? The bank had to define how their bank accounts would look like. Okay, every person, every client will need to define how their bank account should look like. So this is what I and M. Something that I've said here is that every class must be capitalized. So we need to define properties of our bank accounts, and then we need to define what people can do with their bank accounts. Some people can deposit, some can withdraw, and so on and so forth. So this is a very simple one, so that we are at least you're able to understand what you're trying to say. For every bank account that each customer creates, we must define the owner and their initial balance. We can even add more PIN. We can even add what else? Initial deposit and so on and so forth. So if you provide the owner, that owner will be initialized to the class. That's why you're using the init function. It will be initialized to the class. Similarly, if you define the balance will be initialized to the class for every bank account. And now, if people have their bank accounts, there are actions they can do with their bank accounts. For example, they can use their bank accounts to deposit. We can even add more. And then this action, we can even provide them within buttons in the ATM machines that we have. So for simplicity reasons, I just created one action you can do within your bank account. And then what is the beauty of object-oriented programming? Remember now, from one class, we can now create several accounts for our users. So the first account is an object. Maybe it is the bank account. And my initial balance is 100 shilling. Another user comes in, you create another account. The same blueprint, you pass the owner and the balance. So with the one design, I hope you're getting that one. With one design, we can have several bank accounts. I can even add someone else to say account 3. This could be serial numbers. It's for Bob 200. Who else? Account 4. Account 4. It's for who? Charlie. Yes, and so on and so forth. We can say this is now for Alex. Uh, who else do we have here? We are calling the bank account class. Instead of it, maybe we can say, maybe this is for Magna, like that one. Sorry, like that one. So I hope you are now trying to appreciate that with object or application, for example, banking systems, whereby from one blueprint here, we are now defining several accounts, and each account is an object. So in other words, an object is an instance of a class. Okay. So if you want to go and deposit, let's say, who has account one? Eric. Remember, my balance was 100. So if I deposit 50, let's see what I get. Now my new balance is 150. For the second account, if you had initially you had 500, deposit 200, now your balance is 700. We can just print that we are now depositing account. I don't know, Alex, is in which account? Account. Now you call the actions. So remember the attribute. You call the action to deposit. Let's say you want to add like how much? Like 1,000 bob. Let's see your initial balance now. So now your balance is $1,300. And the beauty is also here where we can even define more action. Apart from depositing, we can define actions to withdraw cash. We can define actions to check our balance. I think that is very, very easy. If you want to check your balance, the actions that you use, so I can say check balance. I want to check balance. Sorry. I want to check balance. So you can even add more action. And something to remember, because it's a class, it's a function inside the class, you must call the self argument. So it will actually print the owner and the current balance. So for example, account 5. For example, account 5. For example, account 5, we want to check balance. There's not check my balance. Then they're being told that current balance is 400. This one here. You can define so many functions within that count. So these are real world examples where you can now apply object-oriented programming. You can use it especially if you're building complex application like banking system. In our class here, the reality now in AI, we are going to go through a library called LangChain. I think I told you to research more about it. LangChain. This library was specifically designed for building and deploying AI application and AI agents. So this library uses OOP in such a way that now for us to understand how LangChain works behind the scene, we are going to apply concepts of object-oriented programming. So I think I want to stop there for today. I'll be giving more examples of OOP tomorrow as now we transition into decorators. Anyone with a question? Uh, yes, I've recorded the session as anyone with a question before we now end our session today. And then now we do more examples of OOP to more concept called decorators. Anyone? Okay, so I think I wish to stop there for today. I'm going to share all the materials. I think I've not used my I've not used my slide, but I'm also going to share them with you. It was also trying to just explain what I was explaining, like a class is a blueprint that defines the structure. Several objects. And the real world case is a long chain. So I think we can stop there for today. Let's meet tomorrow. We now advance our Python knowledge as we now introduce decorators, but I will be giving more examples of OOP. Please, if anyone has a question, feel free to reach me through inbox. Yes. Anyone with a question? Fatuma, you have a question? How was the session today? How was the session today? It was insightful. I thought they are very advanced concepts, but yeah, they are very advanced. So we just have to try and understand them. But the best way to understand is you understanding it from your own perspective. From what I'm saying, how do you understand it? That is the most important part here. So with that one, let's meet tomorrow. Enjoy your night. Bye-bye. See you tomorrow.